Hi guys, today we're going to start on the crankshaft for the AT-1 to CT-1 conversion. I'm going to go over some preliminary stuff first, and we'll do some measurements, and then we'll get on with disassembly. Uh, as we're starting out here, if you like our content, please give me a subscription. If you have already, thank you very much. And thumbs up wouldn't hurt either, or a thumbs down, whatever you wish to do. And if you've got any comments, please leave them, and I always read them. So let's get on with this thing. All right, I was pretty amazed at the viewership on the Suzuki crankshaft. It did real well, so I think that people are desiring the information that it takes to put these things together. I'm trying to be as accurate as I can and to do it the best that I can. So let's look at what we've got here. I've got it set up in the lathe, center to center, and the run out here will be you check the left side. I'm calling this the clutch side, this is the mag side. And I'm reading about 1/1000th and a half here. And over on the mag side, I'm getting about 4.5. And although that's probably okay, the Yamaha manual actually calls for one. Let's see, what was 1.4 or something like that maximum. I don't know that you can ever get that. I rarely get that. I'm usually within a 2 or 3. This one is a little far out. This side here, I think it could be done better, but this side over here is doing okay. Now, another thing that they want us to check is the shake here. Let me get things changed here a little bit. Okay, what I like to do is get as much information about the crankshaft before I take it apart, just so if I do have any issues along the way, I can quickly eliminate most problems. Now, they don't tell you to do this, but I always do it. At the rod bearing, where the pin is, I always take an overall width, and now I'm getting, let me see here if I'm zero, nope, not quite zeroed out, got something in there. Okay, 2.203 is what I've got here, and I made a note of that on my pad here. Crank at the pin, and then I'm going to turn it 180 degrees, put the pin on the bottom, and take another measurement. And here I'm looking at 2202. So I've got that jotted down. And I also noticed that the pin actually protrudes out of the crankshaft a little bit on both sides. I don't think it'll ever make any difference, but I'm going to do it anyway. And I've got about 20 thousandths. Yep, 20 thousandths. And I do the same on this side. And that one actually I'm getting about 23. But you want to make sure, because on a lot of these crankshafts, your alignment hole here in the end and the threads and on this end are damaged. People like to hit them with hammers for some reason. I had one that I thought was pretty good, and when I got ready to use it, it was just too beat up. You could never get a center here. You'll have to recut the center. That's the only way you can do it. And you got to take it apart so you work off of these machined surfaces here in order to get your center. But this one's in good shape, so it shouldn't be an issue. Okay, so we've checked our run out. They're saying 0.2. I don't think we'll ever get that. I mean, that's like 1,000ths on both sides. I don't think we're going to get there. This one's not there now, and it's not there on the other side for sure. We've got our crank pin measurement, or crank measurement at the pin, and then at 180 degrees. And then we've got our stick out, and we measured our shake. They're saying maximum is 79 thousandths. We had 40. And the axial, they're saying 19 thousandths. We had 17. So that's just about as much information as you can glean from this as it is. But at least you've got it if you need to go back to it. So let me get set up over in the press area, and we'll take this thing apart. Okay, here's our setup. This is the special little plate that I made. Again, I'm not the inventor of this, but it's a heck of a good idea, and so far it's worked flawlessly. I just put it in this way with the rod to the back, and just make sure everything is free. I don't want to catch the rod or anything. And we put our driver pin right there. And the idea here is that we're pressing 1/2 of this at a time, not both. So it makes it easier on the machine, and it's better on if you've got damage from the pin and the bearing being rusty or something like that. You're not pushing that through the crankshaft haft, which would create an oversized condition, and you certainly don't want that. Now this thing's under a lot of pressure, and when we get ready to start pushing it through, it's going to pop. So stand by. Okay, we've got everything lined up as it should be. Here we go. You want to hold it at the bottom so you don't drop the half. That wasn't near as tight as a lot of them. Okay, now we're going to put it in the other way and finish driving our pin out. And again, this is just going through 1/2 this way. That one's tight. All right, let me get you back over to the bench and we'll take a look at what we got. Okay, everything looks really pretty good. I can feel just a little bit of a burr there with my fingernail. You can see it on both sides, probably where the outside of the bearing was into it. And everything looks good that I can tell. I'll take a quick comparison here, and number one, let's just put them together, make sure they're the same. They look good to me. And we want to check the bottom end width. I'm at 629, and on the original 629.5. And then our top bearing, I've got 715.5 and 708.5, 709. So I think we should be good. Now, one thing that I did notice about this is the weight is a little bit different. Okay, I'm reading about 159 grams there. Yep. And 135 there. You can tell that the Yamaha rod is quite a bit beefier. I don't think there's going to be an issue. I think if if you was going to be a racing or something, you're probably going to have to change some weight on the flywheel part of these, but this is par for the course for replacement. What I think it'll do more than anything is give it a little more RPM, because it's throwing less weight around. But I don't think we're going to end up with any shake. So that's pretty much it for comparison. I guess I should take a look at the pin. I got 866.5 on the new, and 866 on that one. Check both ends here. Yep. So this has got another 0.5 thousandths, so it'll go in a little tighter. Yep, 866.5. And the one thing that you do get is you get your rod, of course, an upper bearing, your 2 washers, thrust washers, and a new lower bearing and pin. So unlike the Suzuki that I did before, it comes with everything. I had to get the thrust washers from Suzuki when I got the Pro X rod for it, but for some reason on the Yamahas, these come with everything you need. This is the number and everything here. So if you need one, this should fit your AT-1 and CT-1. The same stroke. Same stroke. Different bore. That's really the only difference here. So okay, let me get this cleaned up and get it ready for assembly. Okay, I've got the first half set up over here in the press. Let me kind of show you my setup. If you remember, I had a little bit of stick out right here, 20 thousandths. Well, I measured the pins, the length of the pins, and they are about 39 thousandths. The new one is 39 thousandths shorter. So I'm putting a 15 thousandth shim under that, so I don't go beyond that. And We're just going to press the first piece, or the pin in the first half. Going in pretty hard. I'm going to stop and look at it, see where we're at. Yeah, still got about quarter of an inch maybe to go, maybe a little bit more than that. Take another peek. Still got a little to go. Just a little more. I'm feeling that about even with that. So I'm going to stop there. I can always press it more. So I'm going to take you up the bench now and show you what we're going to do from this point on. Okay, we're back at the bench. We've got a pin pressed into the first half, and I can't catch, well, maybe I can catch my fingernail just a little bit there, but it's, for the most part, I'd say it's flush with it. So first thing we've got to do is get us a little bit of assembly lube, and I'm going to put that on all the components. Get it on the pin here and on the washer surface, and the same with the washers. These are a little bit, I can't remember exactly what did I write it down? No, they're just a little bit wider than the original ones, but the original ones showed some wear on them too, so there's our bearing on. I just took these over to the parts washer and washed everything good with solvent. Put just a little bit on the washer surface there. Alright, I'm gooey. Let me kind of get cleaned up and I'll see you back over at the press. Alright, we're back at the press, and I've got my setup here. I did just like I did with the Suzuki. I ran me down, turned down a pin made of aluminum. And this is just to get it close. And after I get it started and it's square on the pin, then I'll pull this out. It just helps me get to closer to my target. Okay, I pulled my pin out. I've got a good start on this. Try to keep everything lined up. Okay. Okay. And I'm going to set it back up at 16. We've still got a lot of room here. Getting real close. I think I'm going to do the next little bit by hand. Okay. It's a little tight. Pressure off to see what it looks like. Yeah, that's a tight 16, but we can get it in there. I'm going to take it over at the lathe and we'll see what the shake is, make sure we're good there. So we'll meet you over there. Okay, we're back over at the lathe. I've got us set up here to check the shake. And the book tells me that after reassembly, it should be between 31 thousandths and 40 thousandths. I've got this on 0 right now. Well, maybe I didn't. It's all the way to the left, all the way to the right. I'm getting 34. 33, 34. So we're good on shake, which means that we're good as far as our axial play. And on that one, it was a little, I was shooting for 16. Yeah, 16. And it's a, I don't know if I can get it in there at all. There. It's pretty, it's snug, but it goes in there. That's 16. So we're just right on where we ought to be there. And now I'll get this set up so we can check our left and right. Okay, here's what we've got. On the left side, I'm zeroed out. That's the clutch side. And I'm setting at about 7.5. And on the mag side, at the same area, I am at about 9, 8.5, 9. So let me pound on it a little bit and see if I can get it closer. It's got to be closer than this. Okay, I think I'm going to stop right there. They want it to be closer than that, but I've done enough of these to know that if you get this close, you better stop. Uh, if you'll see over here on the clutch side, I'm at about a half thou, and over on the mag side, I've got about two thousandths. So I think I'm going to stop right there. Otherwise, you just end up chasing your tail. We've got the proper axial gap. We've got the proper, what do they call that? The shake. The proper shake. And we're within basically 2 thousandths. It's better than it was when I took it apart. I believe we had, let me look here, we had four and a half on this side and 1.5 on the other. So it's certainly better than it was when we took it apart with all new parts now. Okay, let me get back over to the bench, and we'll discuss a little bit here. So back on the bench here, we've got, let's see, we just saw what we had as far as run out here. It's quite a bit better than it was when we took it apart. We have at the crank pin, the width-wise, we had 2.203, and now I'm basically 2.06, and at 180 degrees we started out at 2.202, and I'm at 2.206 and a half, and we had the stick out of about 20 thousandths, and since the pin was a little shorter, I don't have any stick out at all. It's just about flush with the side. Let's see here. Okay, the shake, this here dimension, before we had 40 thousandths, and after the rebuild it says that we should have between 31 and 40, and we have 33. And the axial, that's the dimension here with putting your feeler gauge in there. We've got 16, we had 19 on the old one, and it says you can be 15 to 19. And like I said, the pin, the old pin was 2.177. The new pin was 2.138. So about 39 thousandths difference. And we just ended up with it flush here on both sides. And that, as long as you've got your proper axial dimension, you're going to be okay. And I think that is it. I actually had, I think I hit this 4 or 5 times going back to the lathe each time, center to center, and checking it after each strike with the hammer. And I use a copper hammer. You can use brass. Do not use a steel one. And basically this was, you can take and put just a straight rule across here, and this one was a little bit lower with the rod pin to the back, and that's where most of my dimension was. My pin that I stuck in here, it's a good starting point, but it's not going to get you straight on. And you can't actually put it through the big hole because you'll hit the rod here. You can see part of the rod up inside here. So it has to go over here. But anyhow, I just kind of look at, you know, what we started with, and I went around, I tried to get this as square as I could, and I did that by just, you know, you take your, put this in your palm like this, and just strike whichever side needs to go down. So if this side is lowest, when you put this straight edge on it, then that means this side is highest. So you want to whack this one to try to bring it in line with this one. So that's what you need to do. Very, very rarely you'll have where you're like high or low at the same point on both sides. And if that happens, it's usually this side of the pin, not the pin side. And you may have to take and put it in a vise with some soft jaws and just give it a little squeeze, not much, just a little bit, and go back, put it on your centers again, and check it. But normally you can get all your run out by just by lining these two halves up, and that's using a hammer to strike it with, and then every time go back and check it, otherwise you're going to be chasing your tail. But there we are. And you know, I want to say that you don't have to have a bunch of fancy equipment, a lathe or whatever, to do this. That's what I use because I've got one. You can have 2 V-blocks. You can make a V-block setup yourself. All you're doing is it needs to rotate in some kind of a smooth fashion so that you can put your dial indicators on the top and see what your run out is. You don't have to have a lathe. You don't have to, really the only thing that you've got to have of any consequence is the press. That's really it. And it needs to be a pretty good one, because a lot of times you're going to be close to 20 tons with these. I'm getting ready to have to do one on the 250 Suzuki, and I expect that one to be a lot harder than the 125 Suzuki and the 175 Yamaha here. So anyway, I just wanted to say that, so you don't have to have that kind of equipment. I have it, I use it, but I have done it with far less value equipment, and some of it homemade, so it can be done. So don't be scared of it. Get out there and do it. And if you press it together too far, you can always throw a couple machinist wedges in the middle of it, spread it back apart a little bit. Or if you're really extreme, you'll have to put your plate back in and press it back apart a little bit. But most of the time, if you just go slow, you can get her done. So that being said, if you like this, please give me a subscription. If you have already, thank you so much. And a thumbs up would be greatly appreciated. So thanks for going along on the ride, and we'll see you in the next video.